Okay. Hi, everyone. Welcome to the last video for your Revit structures. This is going to be on Part D. And as the project description shows, Part D is going to be this upper section of the roof framing plan, which includes the sloping of the roof and the roof deck as well. So we're going to jump straight into it, and we're going to go and we're going to start the roof framing plan on our sheets. Um, Key things to kind of note here that I've already started highlighting. Our roof, the roof slopes. It is not 100% flat, and so that means our steel members are going to slope with it. The first thing that you kind of want to see or you want to point out is the sloping directions. So um, you'll see it be told to you in different ways. First is these slope arrows, right? And then also through the designations of top of steel points. Now this is a high point, this is a low point, and this is another high point. It doesn't say high, but we know it slopes down in this direction like that. It does call it a high point here on grid line A, and it also calls grid line E a low point. So it's the same low point throughout. So this whole thing is at a low point. Now, you do have some tricky areas. You have, well, really one tricky area that is not designated to you, and it doesn't tell you the top of steel value. And that is going to be grid line F. You can see that it says that it slopes down from grid line F, but you do not know this value. You'll see that the way that we will find this value is by, and it's a technique that we're going to use to determine all of the sloping, because your members change. So you can't just draw one member the whole way through. They're two different types. So you have to know the top of steel location at the grid lines, not just the points where it's a high or low point, but also some of these in between grid lines as well. So the method that we're going to use is you will draw it as the same beam. And in this case, on grid line 8, when we want to find the top of steel location or height for grid line F, it is all the same beam. It's all a W18 by 35. So you'll see when we get into this, we're going to draw just one nice long beam, cut the beam right here on grid line F. We'll put in the values that we know for the slope to begin with. So we know this is the high point at 41.2, and we know that this is the low point at 43. And when we cut the beam, Revit is automatically going to create the oh my goodness, the height at where we cut it, going along with the slope that we already put in. I know it's kind of hard to understand right now, so I will demonstrate it. This is using oh my goodness, this is kind of our solution file that we have, but I'm just going to draw right next to it on the same grid line so you can see what I was talking about. So if I drew a steel beam, the size doesn't really matter, so I'm just going to I'll use a W shape though. Well, might as well be accurate now. 18 by 35. Okay, so I am drawing it from grid line H, which is our high point, to grid line F, or sorry, to grid line E, which is the low point. We want to know the top of steel location at grid line F, but we need to draw it from points that we know first. So I'm just going to draw from H to E, and then I'm going to put in their different elevations. So we know H is going to be the high point, and we know that the top of steel is 41.2. So that means the start level offset is going to be 41.2. Right now it's using the reference level of the top of wall, so I'm going to change that to the first floor so that it understands me. Okay. And then we also know that the low point of our slope is on grid line E at 43. So we're going to change that to end level offset of 40 space 3. Apply. So now I go into my 3D view. Oh, I did put it. Oh, changed the second floor for some reason. Oh, okay, lovely. 41.2 and 43. Apply. There we go. Now we can see it. Perfect. So now it's at that proper slope. And if we compare it to the other beams, yep, it matches it perfectly. Okay, so now it is at the proper slope between H and E. Those are our two known values. But we want to know the top of steel at grid line F. So all we're going to do is go to our modify settings. We're going to go to cut or split element, and we're just going to split the element on grid line F. And when you do that, Revit is going to automatically calculate that value for you. So coming from H, which was our high point, the value, the top of steel value for F is going to be in that end level offset, which we can see is 40 feet, 5, 181 by 256. Crazy number. But what's nice is that once you get the number once, you can just copy and paste it into every other member or beam system. And then you'll see that it matches the start level offset when we're looking at the beam between F and E. So that matches, and that's perfect. So that is how you're able to determine the top of steel at grid line F, which is our one weird one. The rest of these, they do give you the values too. However, you do have grid lines like D and G where you have either two different members following that same slope. So it's going to be a very similar process as that we did here. So I'm just going to redo it just for funsies. So let's say I'm going to just draw it as the same beam for now. So it's going to go H to E, classic. But now it changes at grid line G. We're going to put in the same offsets. So I'm going to put that 41, oops, 41.2. Oh, okay, let's change it to first floor and it's going to go crazy. 41.2 and 43. Enter. Apply. There we go. So now it has the proper offset in proper sloping. And this time we're just going to cut it at grid line G instead of F. And if we do that, oh, my cut wasn't perfect. It's okay if it's not like the most perfect thing. It gives us the slope now at grid line G, and we can just go and change that member into the proper member it's supposed to be, which is a these are the same on the outside, but on the inside it'll be 12K1 versus an 18K9. So let's just pretend we're doing our joist. So 12K1, and this one is going to be an 18K9. Bam. So yeah, so now you have those two separate types of joists. You can see they're very different, but they are at the proper slope. And again, it matches with our other slope that we created. So yeah, I mean, that's basically how you do it. And once you get the value, you can just copy and paste it for your different members or beam systems. And yeah, nothing too um nothing too crazy here. There is a method where you can do it, mathematically, but it's just much easier if you do the cutting method and Revit calculates it for you. Now, another thing that is important is that when you do calculate the top of steel values for like the G grid line or the grid lines where it's not given, like G, F, and D. And I don't think you need C. Yeah, no. So yeah, G, F, and D. Um, if they do have horizontal members on them, they will just be um at that top of steel value um from 00. Uh, but you will also reduce it by the -2.5 if it says it. So this one says -2.5. This says -2.5. So yeah, you would also reduce it. So you would just add on that -2.5. So in the case of grid line G, right, we just did it, that end level offset was 40, 10, 59, 256. So if I drew a horizontal member on grid line G, its Z offset would be this value, Control C, Control V, minus 2.5 inches. And oh, I need to put the equation sign in the front. My bad. Ah, equals. And then it would, oh, I forgot that I definitely didn't change the reference level. Ah, oh, and now it doesn't want me. I'm just going to Control C that just in case it deletes it from me. Do, 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 do. Oops, I meant to press 0, sorry. I'm not sure why it's not letting me mess with. Let's go here. I'll just delete it and I'll redraw one. Not sure why it's not letting me mess with that. I'm gonna put the reference level. Or I guess what you could do is if everyone knows our top of wall reference level. That is zero. Your high roof is 42.8. So you could just go take this for your Z offset. You can go equals 42 feet, 8 inches minus that value we calculated. And it puts it at 2 feet. And what are these ones at? Oh, these are -110. Yeah, that's a better way. Mm-hmm. Go Control V, Control V, Y. Put that on the first floor. Control V again, fly. And then we can see if they're on the same level. They should be. I actually cannot tell. Let's see. Let's see if I did this right. Oh, it's a little bit less. Yep. Now, I wonder if I didn't put in the negative 2.5. Sorry, guys, I am experimenting over here. Um, you could probably Control C. Hmm, you can probably. Oh, you know what? It is not the correct type of beam. Yeah, it should be a W16 by 36. That's why it looks weird. Now let's see. 16 by 36. Item view. Elements. All right, pretty close. Literally by the tiniest bit. Um, but it works. Yeah. I mean, we could put in those 2.5 inches. Let's see. Um, put in equals minus 2.5 inches. Enter. Okay. Control C. Control V. Apply. Ah, I put it really low. That is weird. Oh, that negative 110. This one is at the low point, so that's easy. This one is at negative 2.5, which, because it's 42 hmm, elevations. The high roof is 41, 6.5. Oh, that's right. 41, 6.5. And so that is 40. Mm-hmm. Say equals 41 feet, 6.5 inches minus, oh shoot, close. I should have Control C this. Mhm. It's like 1 foot, and that's at 2.5. Oh, that's right. I keep making that mistake. Hmm. All right. Delete. I'm not sure why. Oh, okay. Yeah, no, I was correct. Um, my apologies. You don't want to add in the negative 2.5 because you already account for it when you do the sloping. So you will keep it at the Control C, the slope you obtain, or the number you obtain. Goodness gracious. Um, when you cut, Control V, Control V, apply. It gets it very, very close to your other values. And actually, that's, yeah, very, very close. And if I did the same for, oops, let's just make sure nothing's floating in the air. Yep. And if I did the same for grid line F, where if I made a horizontal beam and I put Control C, Control V, Control V, change that to first floor, Control V, Control V, apply, and I look at it in 3D. Oh yeah, they are very, 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 very similar. And I gotta make sure they're actually the same type of beam. So W16 by 26 by 26. Apply. And yeah, they're basically at the same spot, give or take a fraction of an inch. Um, but pretty good. So yeah, just go with the value you obtain when you cut because it already accounts for the negative 2.5 inches, so you don't have to add it back in there. Sorry for the very long way to say that, but I guess it is kind of nice to see the process. So yeah, that will be everything that you'll need for the sloping. And then for the roof, oh my goodness, the roof slabs or decks themselves. As you can kind of see here, it's a little bit easier. Um, so like when you draw a roof, we all know how to draw a roof. You're able to slope it. You did this last year in your architectural model. Um, it's just a little bit easier to kind of divide the roof into sloping areas. But you can really play around with that when you get to it. You guys all know how to create a roof and slope the roof. So if you do that, you just go roof, draw your rectangle, make whichever sides that are going to slope. So if it's sloping downward, this is the only sloping side. Oh, actually, no. Ah, actually, you can just use a slope arrow. And if you do a slope arrow, you're able to put in the height offsets at the tail and the point. And you can do it that way, or you can slope the specific lines themselves, offset from the base. Very many different ways to slope the roof. But you guys know how to do it. And just another thing to make sure that you do is, put the roof deck on properly so that includes the metal decking and the concrete. You can find all of that information in the drawings. So yeah, this one is pretty quick. Not too bad, not too much. Definitely a lot less than part C. And once you get the sloping again for those few grid lines, you're able to just copy and paste those numbers. All right. See you guys later.